In this video, we are going to learn how to solve problems involving elasticity for your JAMB Physics. So we are going to practice with 10 repeated questions for this topic. Let's get started. The first one I have here says the diagram above represents the graph of the force applied in stretching a spiral spring against the corresponding extension. The force constant of the spring is what? Alright, so for this particular question, we have the graph to be this graph plotted force against the corresponding extension. So we're going to use the formula for slope to get the force constant of the spring. So we use y2 minus y1 over x2 minus x1. So basically, let's call our y2 to be the highest value of the force there, which is 120 minus the least value, that's 40, over the x2 will be the highest value of the extension, that's the length, we have it to be 6, minus the least value there, we have it to be 2. So when you break this down, you're going to have, so 120 minus 40, we have 80 over 4. So 80 divided 4, you're going to have the output to be what? 20 Newton per meter. And that will be the answer to this question. The correct option is what? Option C. Okay, so that's it for this question. Let's wipe this and solve the next repeated question. So the next repeated question will be this question. It says the point at which the molecules of a loaded wire begin to slide across each other, resulting in a rapid increase in extension is, we have option A, deformation point, proportionality point, yield point, elastic point. So the correct option in this question is option C, which is yield point. Let's go to the next repeated question, which is this question. It says in an experiment to determine Young's modulus for a wire, several loads are attached to the wire and the corresponding extensions measured. The tensile stress in each case depends on the, we have option A, load and the radius of the wire, option B, extension and the original length of the wire, option C, load and the extension, option D, radius of the wire and the extension. So the correct option to this question is option A, which is load and the radius of the wire. So let's go to the next repeated question, which is this question. We have it to be, we have this diagram. The diagram above represents the stress strain graph of a landed wire. Which of these statements is correct? J is the yield point, L is the elastic limit, at K the wire breaks, at J the wire becomes plastic. So guys, the correct option to this question is option A, which is J is the yield point. Alright, so that's it for this question. Let's go to the next repeated question, which is this question. It says the diagram above represents the stress strain graph for a typical metal rod. What does X represent? So X basically in this diagram represents the breaking point. Alright, so that's the signification of X here, breaking point. Now take note of these charts I'm showing you. This is the first one I looked at, this is the second one. I have often seen these graphical illustrations repeated, so take note of this graph and what each alphabet represents in the diagram. Alright, so that's it for this question. Let's go to the next repeated question, which is this one. Okay, it says a force of 500 Newton is applied to a steel wire of cross-sectional area of 0.2 meters square. The tensile stress is what? So before you solve this question, if you are new to our channel, ensure that you are subscribed to this channel for more of our videos. We really appreciate this, guys. So to solve this question, all you need is to apply the formula for tensile stress. So tensile stress, let me present you with capital letter T equals force over area. So when you input the values, it will give you 500 divided by 0.2. Alright, so let's punch this on the calculator and see what's going to give us. We have 500 divide 0.2. So we have the output to be 2500. So another way you can express 2500 if you want to put it in standard form is something as 2.5 times 10 to the power 3. Alright, let me show you. We have 2500. If expressing it in standard form, you go backwards 1, 2, 3. So we move 3 times. So this is something as 2.5 times 10 to the power 3 meter per meter square. Alright, so the correct option on this question is option C. Alright, so that's it for this question. Let's look at the next repeated question, which is, let's write this. Alright, so the next repeated question will be this question. It says, from the diagram above, the point that represents the elastic limit is. So guys, be taking note of these diagrams and what each of the alphabets represents. So for this question, the correct option is the point that represents the elastic limit is point R. So option B is the correct answer. Let's go to the next one, which is this question. It says, from the diagram above, the point that represents the elastic limit is. I think we can answer this question is point R. It is a question we just finished answering. They repeated it. So let's go to the next one, which is this question. It says a copper wire was subjected to a tensile stress of this value. Calculate the tensile strength of the wire. We have the Young modulus to be this. So basically, you know that the Young modulus is tensile stress over tensile strength. Alright, for Young modulus. So we have the Young modulus to the 1.1 times 10 to the power 11 equals, we are giving the tensile stress to the 7.7 times 10 to the power 7. Okay, over, I'm looking for, it has to calculate the tensile strength. So let's call it x. When it equals multiply, we're going to have 1.1 times 10 to the power 11 x equals 7.7 times 10 to the power 7. So this is 7, guys. So when you make SI formula, divide both sides by 1.1 times 10 to the power 11. 1.1 times 10 to the power 11. So this will cancel these. Our x will now be, when you apply the law of indices here, we have the base the same. So it will be the base, the power 7 minus 11. This is 11, guys. So 7 minus 11, we have 10 to the power negative 4. Okay, so basically we now have 7.7 divide 1.1. When you divide, they're going to have 7 as output. So it will now be 7 times 10 to the power negative 4. That will be the output, the correct expression for this solution. So the correct option in this question is option D. So the Young modulus is 7.0 times 10 to the power negative 4. Alright, so that's it for this question. Let's wipe this and look at the last repeated question. Alright, so the last question I have here is this question. It says a force of 500 newtons is applied to a steel wire of cross-sectional area. The tensile stress here, I think we have solved this question before. We got the answer to be option A, 2.5 times 10 to the power 3 Newton per meter square. Alright, so that's the correct option. It's as simple as this. So guys, this is basically you can do problems involving elasticity for your JAMB Physics. We practice with 10 repeated questions for this topic. Let's go to the video, guys. If you are new to our channel once more, ensure that you are subscribed to this channel by hitting the subscribe button for more of our videos. Also like, share and comment on this video. Tell me how you feel for what I learned from this video. If you seem to have any specific questions to ask regarding what I talked about in this video, feel free to leave your question in the comment section below. I'll be sure to give you a response. Also ensure that you're part of our channel membership by hitting the join button to be part of the community. In our channel membership, we share special information and help those there to have the academic work simplified. So join us and we'll be glad you did. Now click on the screen above and I'll see you in the next video. Thanks for watching.